Okay, so addition polymerization only happens to alkenes. So like double bonds. Let me just write that. Double bond. Okay, so for example, let's say you have an ethene, C H H H H. Okay, and let's say a question says like that you have n times of these alkene, and then you basically want to make a polymer from that. So what you're gonna do is I like to first, if you have like a bigger monomer, you're gonna want to rewrite it in the form where the double bond is like in the middle, and then you have the vertical groups like above and under. I will show you like an example later with an exam question maybe, but yeah, it helps if you make it like that way. So you want to break this apart, and then it becomes C C H H H H N. Okay, and well, you would notice that it's just like this. You kept the form. Okay, it's just that the double bonds are now like this way. Okay, so yeah, that's a lot easier to understand. And the repeat unit is whatever's inside the bracket. Okay. Okay, now moving on. Condensation polymerization. Okay, this one happens to anything with two functional groups. Okay, groups. So what that means, so I'll show you an example. So let's start with I'll do a dicarboxylic acid. I think, oh actually, yeah, H C 2H4 C OOH plus okay. Sometimes they might write this middle bit as like a box, okay, different color boxes. So I might just do that. Let's do a blue for this one. Yep. Okay. COOH. And for the other side, notice that the carbon is bonded to the carbon, so you can't write COOH even though it seems right, because if you write COOH, that means the middle part is is bonded to the hydrogen, which is wrong. That doesn't make sense. So you have to write COOH. Okay, and then plus you do the same for this one. It's H2N dash. Now, even though it's the same, it's a good habit to write it as a different, to like do a different box. So in the exam, obviously there's no like colors or anything, so you might have to do like a white box and then the other one like a shaded box. So okay, NH2. Okay, so for condensation, you basically want to make H2O. Okay, so for this, you've got, well, you only have an oxygen from like this part, right? There's no oxygen here, so this part you have to take an OH, and then from here you have to take 1H. Okay, so basically I'll show you on this one because it looks neater. So you take this, and you take this, and then you take this, and then you take this. Okay, so then do it here. Okay, rewritten, it would be, I could just copy this. Okay, so C. I'm gonna draw out the bonds for you so you can see how it looks like. C O plus, oh, we're not doing a plus, and then H N H C, would be this, N H. Okay, and don't forget to plus H2O because you're making water, remember? Okay, so the part that you connected the two, so this middle part, is called a linkage, but because it's a CO and H linkage, it's an amide. Okay, it's an amide linkage, which is CO and H. Okay, so the next example, next example, let's do O C. It's the same carboxylic acid, and let's do a different color. Let's do maybe purple. C O O H plus H O. We can do green. Oh, sorry. Green. Okay. O H. Okay. So again, we're still making water because, you know, condensation produces water. If you think about it, like regular condensation process, you have a cup with water and ice in it. Condensation is the water on the cup, so it makes water basically. Okay. Okay, so again, you're making water, right? But the thing is, this has O and this has O, right? And it has a H and it has a H, so you don't know which one to like cut. Another type of linkage that you can form is called an ester linkage. Let me just ester, and it makes a COO. So you have CO here. So if you break this, you have CO and you have a bond. And then if you keep the O here, you have another bond and you get rid of this, which means you have H2O, right? So it's this and this that you want to get rid of. So it's this and this, okay? And wait, so let's draw that. Okay. Duplicate. Double bond O. Ooh. Double bond O. O. Let me move this up. Okay. Okay. And then don't forget the plus H2O. Okay. And obviously this ester linkage is CO. Okay. Okay, now we can try some examples. So it says that Fig 7.1 shows the displayed formula of compound S. Compound S can be converted to acrylic acid. The molecular formula of the acid is C3H4O2. Complete the table to calculate relative molecular mass of the acid. Okay, so should be pretty straightforward. C3, 3, H4, so 4, O2, so 2. And then these you could find in the periodic table. Relative atomic mass is the number below the element, okay? So you should have the periodic table either on the front or on the back of the exam paper. So carbon is 12, it says 12, and this is 12, so that's right. Hydrogen is 1, and that's also right. Oxygen is 16, and yeah, that's also right. So now we can continue. 4 times 1 is 4. Oxygen is 2 times 16, which is 32. And the relative molecular mass is the sum of all of this. So 36 plus 4 is 40. 40 plus 32 is 72. Okay, so moving on. It says the acid is an unsaturated compound. Describe a test for an unsaturated compound. So you should know that you have to use aqueous bromine, okay? And the observation is that it turns from brownish orange to colorless, okay? And this one says, when left in air, the acid forms a polymer. State the meaning of the term polymer. You should know that it is a long chain of molecules, okay? And it is formed from monomers, okay? Because going back to this, remember that this is a monomer and this is a polymer because this is 1 when n equals 1. And this is when there is an n number. Okay, so it says polyethylene is also a polymer. Choose from the list the type of polymerization that occurs when a polyethylene is made thene. Okay, it's an alkene. An alkene should be additions only. Okay, next question. It says a list of symbols and formula is shown. State which symbol or formula represents the monomer used to produce polyethylene. Okay, so polyethylene, MEPB, so that is 2 carbons, right? So let's go through the list. And it's this, and it's this. The monomer used to produce this, remember it starts off, for addition polymerization, it starts off with an alkene, okay? So alkene should be C2H2N. So that is, or if you draw it out, you know it's C2, and then you can fill this up. It's H. So it's gonna be C2H4. Okay, now for the next question. It says but1-ene undergoes polymerization. State the type of polymerization but1-ene undergoes. Okay, ene, alkene, addition. Okay, draw part of the polymer molecule to show 3 repeat units. Okay, so we started with but1-ene, right? So let's draw how but1-ene looks first. MEPB, so but1-ene has C4. Okay, so 1, 2, 3, 4. Okay, and it's 1-ene, so the double bond is at the first carbon. So now we can draw the hydrogens. 1, 2, 3. So we have 1 here, and then 1, 2, 3, 4. H, and then you can just do CH3. Okay, and remember, as I said earlier, just we can put it in the form where it's C double bond C, and then vertical, 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 vertical. Okay, so if we do that, it then becomes, we can do C double bond C, and the first C is bonded to this and this. Okay, so it's 1H, 1H, and then the the second bond is, the C is bonded to 1H, and the rest of this. Okay, so we can do H and then CH2 CH3. Okay, makes life much easier. Now if we want to draw now we're going to draw one repeat unit. Okay, so that becomes CH H, we're just gonna split the bonds. CH, CH2, CH3. So if you notice, if you put it in this format, it's nicer, it's easier to work with. So you can just do that, and then N. But now it says 3 repeat units. So N equals 3, which means we could technically just copy paste this. Duplicate. Boom. Boom. 3. Ta-da. 3. Okay, next question. The structure of compound A is shown in the figure below. Deduce the molecular formula of compound A. So, molecular formula is just like how many numbers of carbons, how many numbers of hydrogens, and how many numbers of oxygen, or basically just whatever is in the thing. Okay, so carbon, 1, 2, 3, 4. So it's C4, and hydrogen, 1, 2, 3, 4, 5, 6. Okay, and then oxygen is 1, 2, 3. Boom. Okay, there are 3 functional groups. Name the molecules. Okay, functional groups. So double bond should be an alkene. Okay, OH is an alcohol, and COOH is a carboxylic acid. Carboxylic acid. Okay, state was observed. You should know this by now. It turns colorless. Aqueous NaCO3. It's should be what is it? The smoke. It should be effervescence. Give me a second while I check the mark scheme. Okay, so all of these are right. This is right as well. This is right as well. But instead of effervescence, you can write fizzing, or you can write bubbling. Okay? Or just bubbles, whatever. Okay. Compound A can be used as a single monomer to produce 2 different polymers. Draw 1 repeat unit. Okay. So notice that the question is asking for the repeat unit of the addition polymer. Okay. So that means we're breaking the double bonds. Okay. So I'll just draw it here and then I'll bring it down. COOH, H, CH, CH2OH, N. Okay? Bring that down. Boom. So that's 1 repeat unit. Yep. Okay. Name. Wait, you don't have to do the N, but I prefer to keep it there. It's not wrong, but you don't have to do it. Compound A can be converted into a dicarboxylic acid. Name the type of condensation polymer formed. Dicarboxy acid and diol. So you have OH and COOH, right? So you want to make this and H. because it's either we make a amide, which is CONH, or we make an ester, which is COO. So this one CO, and oops, sorry, I canceled that O for no reason, and then O. So we're making an ester. So it is a polyester. Boom. A list of gases is shown. Answer the following questions. Each gas may be... Okay. Give the name of the gas that can form a polymer. Ethene, because that is an alkene, so it's ethene, and nothing else by itself. Carboxylic acids can be converted into esters. Polyesters are polymers made from dicarboxylic acids. Name the other type of used in... Okay, so we have COOH, and for polyesters it's COO. So this and an O. So it can be alcohol. Oh, it's instead of alcohol, it's a diol. Okay, because remember it's like COOH, and then whatever boxes, and then this side is the same because it's dicarboxylic acid, so then it has to be a diol. OH, okay, has to be a diol. Name the type of polymerization used in the manufacture of... Oh, okay, so this should be straightforward. It's condensation. Okay, now final question. Polyesters can be made from two different types of molecules as shown. Polyesters, so COO. Complete the diagram to show a section of the polyester made from these two molecules. Okay, so COO, we have the CO and then the O, okay, which means we want to break here and break here. So these becomes the water, right? Okay, so what we can do is we draw them separately first. So all of the gray ones will just draw this part, and then all of the white ones will draw this part. Okay, so C double bond O, C double bond O, C double bond O, C double bond O, and the white parts are just O, 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 O. Okay, and then we draw bonds in between them, and like also at the ends. Okay, so then notice that this would be the ester linkage. Oh, the ester linkage. So boom and boom. Oh, well, this part and also this part technically will also be it. Okay, so name the type of polymerization. Should also be straightforward. It's condensation. Okay, and that is the end.